than an entire lifetime. And that was back when New York Times was just a printed magazine. And now it's all online, and it's pretty much a continuous stream of information that never stops or even seems to take a break. So that global overload of information that we're subjected to can be pretty overwhelming, right? Sometimes we wish we lived in less interesting times, maybe simpler times, less turbulent times. It's only natural that sometimes we wish we could just disconnect. But this global surge of data is actually not all evil. It also brings us beautiful things like unprecedented sense of global connectedness. That's the World Bank I told you about I was going to talk about, right? And if we think about it, we really never felt more connected to the rest of the world than we feel now. Internet, computers, and technology has brought us things that now we take it for granted, that we can be pretty much anywhere in the world and still get a real-time, front-row view of the breaking news halfway around the globe. And that's pretty beautiful. And things are going to get only more interesting. According to Cisco, there are 80 devices connecting to the internet every second in 2013. In 2014, it's projected that this number will reach 100. Will be 100 devices connecting to the internet every second. And it's projected that by 2020, we're going to have 250 devices connecting to the internet every second. If we add up these numbers, by 2020, we're supposed to have whopping 50 billion connected devices around the globe. To put things in perspective, that is more than 7 connected devices per every human being on this planet. Not only that, but the majority of the growth is going to come in smart devices, the devices that we interact with every day throughout the day. It's going to be the smartphones that we carry around everywhere. It's going to be connected cars. It's going to be connected homes, wearables, things like that. So this 50 billion of smart devices that are all connected and watching us can be quite intimidating. To be perfectly honest, it can be kind of scary. And yet, I don't see too many scared faces around me. What I see is a lot of excitement. I see a lot of people who are extremely passionate about building all kinds of very interesting things for the Internet of Things. These are interesting, exciting people. These are people who are ready to meet the challenges and the opportunities of the Internet of Things head on. It's extremely inspiring to be around these people, to be around people who are building the future as their full-time job. And yet, despite all this excitement, I want to urge you today to slow down. We're entering the era and the environment that is fundamentally different from what we have now. 50 billion connected devices. In this new environment, we really need to make sure that we're not doing something silly, right? There's a sign when they are warning about dry paint. What could dry paint do to us? We need to make sure that in this rush of excitement, the things that we're doing is still making sense. And you know, for decades now, we, the computer developers, how many engineers in the room? Yeah. So for decades now, we, the computer programmers, have been borrowing, copying, stealing, imitating the terminology and mannerisms of civil engineers. We even call ourselves software engineers. But the reality is that software engineering was never really like the architecture of the buildings or the architecture of the bridges. In the real architecture, the cost of making a mistake is very high. If you design something wrong, the building will collapse and the bridge will sink. Whereas the predominant philosophy in the software engineering has been just ship it, right? A lot of times, it's more important to ship things. Minor errors, in most cases, do not matter. Pretty cost-effectively, we can fix them later. Well, the reality is that with the 50 billion connected devices, we will be building a lot of software, a lot of APIs that other applications depend on, other devices depend on. And we cannot really change how these behave without breaking millions of applications or potentially billions of devices. So welcome to the world. We're really dealing with real architecture, the architecture that has long-lasting consequences.
So one of the ways they solve that is,
Go ahead, now you have a break.
Somebody phone Ping IT.
and what they do is they over-engineer it so that they can deal with flaws and deal with mistakes that was made and stuff, and it still stays stable. That's a different thing than trying to engineer it perfectly.
Yeah. So that's a very good point, that over-engineering is definitely not a solution. So we're going to talk about several things now that are both simple and yet provide the resilience and robustness that we need for something that really needs to last the time and not sink and not collapse.
You will tell me when to click.
That's good. No, we're at the perfect place.
Okay, but the clicker's not working anymore, so you will tell me subsequently. Go.
You want to try another clicker?
No, the USB thing broke.
Oh, I'm sorry.
No, no.
Okay, so I'll tell you. So this new reality of the Internet of Things is a very complex distributed system. And in many ways, it's by its own nature a chaotic system. And chaotic system in a mathematical sense, in which small mistakes have exponential consequences in the end. And yet, despite all this complexity, we really need to make sure that things just work. When we're trusting software to run crucial things in our lives, like our cars and our homes, the margin of error is really zero. So today I'm going to talk to you about three things. There are many things in general, but I'm going to single out three things that I believe are crucial to build these resilient, time-lasting architectures that we're going to need in the Internet of Things.
Say Bing.
Thanks. So number one thing is, if we're going to build something this complicated, we better learn from our past. And the largest, most distributed system humankind has ever built is World Wide Web. And it has been around for 20 years now, and it kind of works. A lot of nice things are created on the web. It's highly distributed, and a lot of people are working with it. So there's a lot we can learn from the architecture of the World Wide Web. And better yet, a whole bunch of very smart people have been looking into the architecture of the web, once we knew it was successful, and trying to identify what is in the architecture of the web that makes it so resilient, so scalable, and last for such a long time. And basically, they came to a conclusion that we had to choose one thing. It's the hypermedia that gives web most of its good properties. So what is hypermedia? Hypermedia is basically a matter of which the World Wide Web is made, right? So our physical world is made of elementary particles, fermions and bosons. And much like that, our digital space, the World Wide Web, is basically nothing else but a myriad of interacting hypermedia documents. So this word hypermedia may sound a little bit intimidating, but it's actually very simple. And all of us in this room, I believe, are familiar with at least one type of hypermedia. How many people know HTML? Right? HTML is a type of hypermedia. That's what all of our websites are constructed from. And we take HTML for granted now because it's been around for so long and because it's so simple. But HTML is really magical. If you think about it, what HTML is, it's a handful of very simple rules, about 24 very simple tags. And those tags combined in enormous amount of ways can give us anything from an entertainment website, from our banking website, government websites, all kinds of things can be built by combining the simple rules in an endless ways. And HTML is not the solution for everything. but it's very magical. And if we're going to build something as great as the World Wide Web, Internet of Things, we need something that is as magical as HTML. Except HTML was mostly designed for rendering of content. On the Internet of Things, we'll be marshalling around structured data, right? HTML was designed for unstructured data. And HTML, while it was not necessarily designed for HTTP, it's very closely correlated to HTTP. And we may not be using HTTP for a lot of Internet of Things things. But that's OK, because we can go to the next slide. Because HTML is not the only hypermedia type, and a lot of work has already gone and is being put into designing hypermedia types that are magical like HTML, but are more geared towards Internet of Things. These are standards like Uber, Siren, HAL, JSON API, Collection JSON. They will be the engine of Internet of Things, just like HTML used to be for the World Wide Web. Next one, please. So that's one thing. Another thing is that APIs are extremely important for Internet of Things, because APIs are really the digital pipes that can take data from anywhere to anywhere. This is the only universal way for us to get data and functionality to pretty much everywhere. And yet, there is a significant problem with the current state of APIs. And we need new breed of APIs, which I call linked APIs, if we're going to overcome the significant flaw of how APIs are designed right now. The problem with the current breed of APIs is that even the largest, most known APIs, those from Google, Facebook, Twitter, APIs that we all align after, they all have a significant problem in that, at best, they are narrow windows into the solid walls that surround the highly guarded data sets. All these APIs, they can only work on the data sets that is stored in their own databases. If you think about like a Twitter API, Twitter's public API, it's a wonderful API. You can do a lot with Twitter's API. A lot of people are building applications around Twitter's API. But at the end of the day, all of the content that is created on Twitter is only stored on Twitter's databases. Think about it. All of that content is only stored on Twitter's databases. So in that sense, these APIs, what they are doing is they're creating data silos, right? They can only work on their own data. And that is extremely anti-web. Web was created in the spirit of decentralized, equal participation. On the web, anybody can publish anywhere, and we can still get to the data and the content through search, through feeds, through hyperlinking. APIs have not matured to that extent. Most of the APIs can still only work on the data that they store themselves, and virtually no API links to another API. Linked APIs are a design paradigm that are supposed to fix that. And they use hyperlinking and controls a lot, because hyperlinks have played a crucial role in the growth of the web, and I believe that they are going to play equally crucial role in the growth of Internet of Things. And let's talk about identity for a second. Any Google employees in the room? Okay. So I'm going to single out Google a little bit in this part of conversation, and I really like Google. I like a lot of Google services. I use a lot of Google services. The only reason I'm singling out Google is because it's the biggest, most known, most familiar example. So please don't be mad at me. We can still be friends, okay? So with that said, I have to say that we have gotten very frivolous with the notions of identity and privacy on the web. A lot of large companies have started insisting on so-called real identity. And one of the most unfortunate examples of this was how about a year and a half ago, Google started unifying identity across all of its services. On YouTube, you had to use the same identity you were using on the Google+. Not only that, but they started insisting on real identity. to the extent that if they thought that your identity was not real, they have shut down accounts for that. And that's a huge violation of privacy on the web. And actually, as I was preparing for this talk, like literally from when I sent the slides and before I had to come here, I read that Google has reversed this policy, and they are not insisting on real identity anymore. And I sincerely appreciate that, because this is fixing a huge flaw. A couple of months ago, I was at a very interesting conference, Computer Freedom and Privacy Conference. Anybody has heard of this conference? It's a very traditional conference. Has been held for 20 years now. It's organized by Association of Computing Machinery. That's, by the way, same organization that gives Turing Awards. There were a lot of very interesting people at that conference. A lot of the most prominent human rights, freedom of speech, and privacy advocates were at that conference. And it was very interesting to meet with them, because one of the things that we often forget is that web is the #1 platform for people who are fighting for freedom of speech, people who are fighting for human rights, people who are fighting for our privacy online. And when large organizations insist on real identity, what they are forgetting that it's not just a matter of some silly kid posting something inappropriate online that may or may not affect their employment opportunities, which is also an important thing. But what we really are doing when we're ignoring these privacy issues is that we're putting in danger the life of the people whose safety literally depends on their ability to remain anonymous. There's a lot of harassment, unfortunately, going on the web. And there are a lot of people whose literally safety depends on their ability to remain anonymous. We may not forget this. Not only that, and it's not just a matter of safety and security, but when we insist on a single so-called real identity, we're actually ignoring how things work on the web, in real life. And in real life, we don't really have one single identity, right? Identity is this notion that is a set of attributes that are interesting about me. That is what identity is defined in academia. And we as humans don't have a single identity. My identity on this conference is not the same as my identity with my colleagues, or my identity in a bar with my friends, or my identity with my family. In reality, we have multiple identities, multiple sets of attributes that are important for people. And unfortunately, because of simplicity, because of ignorance, because of whatever reasons, the software engineers, we should take blame for this, have simplified the space of security to be authentication, and then there is authorization. They have conflated authentication with identity, which is not right. Authentication is about establishing the trust relationship. Identity, which is the set of attributes about who I am and what is interesting about me, is a separate concern. And good frameworks like OAuth to actually take that into account. But unfortunately, in a lot of software that we write, we do not do that. Another example of that gone wrong is, again, Google services. Did I mention that I really like Google? I did. I have multiple Google accounts. I have my personal Gmail. I also have multiple projects I participate in that have vanity domains, so it's a different Google account. And at my previous job, we also used Google services from a branded company account. So I have multiple Google accounts. And if you have ever used multiple Google accounts, it can be bane of your existence. It's very, very annoying, especially if you're security savvy or security concerned and you use multi-factor authentication. You're going to have to do multi-factor authentication with each service. And let me just tell you, that is not pleasant. And it's also unnecessary, because Google needs to only establish the trust relationship with me once. I'm one single human being. And then acknowledge the fact that I do have multiple identities. So the right way of doing things would be, let me log in once, let me have one way of multiple authentication, and then let me choose the identity that I want to use in the context that I am with.
But you're assuming, by the way, that that's okay from a privacy point of view, that Google knows that those are all the same user. You as a user may not want that, so it could be choice. There's a choice thing.
It could be a choice thing, but in a lot of cases, it is okay. And the problem is that if I want to have multiple accounts, I obviously will be able to have multiple accounts. But if I have one account and multiple identities, which is how people actually live and go around their lives in most cases, there is no way of doing it. Google and most other systems actually make you have multiple accounts, and that system does not work. So I think what we need to do is, I think we need to acknowledge how things actually work in real life. Acknowledge that when we build models of something, they are just that, they are just models. And we need to do that as soon as possible. Because when 50 billion different devices come online, that means enormous amount of context in which we will have to authenticate ourselves. And if we have to authenticate ourselves individually in each of these contexts, that's just going to be a nightmare. Right? So we need to start doing things the right way. And until we figure out what these right ways are, maybe we should not rush into things. Maybe we should take our time. Thank you very much. So this is my contact information. If you want to follow me on Twitter or yell and scream at me on Twitter, that's all of that is fine. I believe we have a couple minutes, so I can accept some questions. Cool, we'll do it on Twitter.
I have a question.
Sure.
Linked APIs you talked about, it implies a RESTful model for API interactions, right?
It's actually orthogonal to the RESTful or hypermedia type. It is orthogonal to hypermedia type as well.
So what are the implications for things like OAuth, for the authentication models, how you authenticate to those APIs if you're chaining these API calls?
So linked APIs are mostly for machine-to-machine communication. So this is what happens behind the scenes. And the main concern there is, you're familiar with the notion of unbundling? So basically what you're trying there to do is you're trying to leverage the economic force of unbundling your data storage from your interface. Like right now, your API is both your storage as well as your interface with people who are communicating with you. So that is the main concern of linked APIs. RESTful hypermedia APIs also use links a lot, but there the concerns are different. So they are highly compatible because they both try to use hyperlinks, but for different end goals. Thank you.